All right, I asked you guys, and you guys blew up my email with a bunch of questions that you guys had from the homework, and I told you I'd help you solve them. I've been sick a couple days, so it took me a while to get to them, but here we go. We're going to hit all of them in one quick video. The percentage of people accessing the internet in a given area increased from 66% to 88%. Now, there's two ways we can talk about the percent change. We can talk about in absolute terms. We can say, how much did the percentage go up in percentage points? And the percentage of people that access the internet went up from 66 to 88. So we can just subtract those and we get 22%. The other way we can talk about it is we can talk about it as a change relative to what we started with. So that would be take the 22, the absolute change, divide by what we started with, and we get 0.3333, and as a percent though, so we're going to go ahead and multiply that by 100, and that's going to be 33.3%. So we have absolute change and relative change. Absolute change, we just have to subtract to find the difference. And relative change, we have to subtract and then divide by what we started with. On a particular day, there were 3,365 deaths attributed to a virus in a particular country, and there were 125,280 new cases. The question is asking us for the ratio, the percent, the number of deaths is what percent of the total number of new cases. So we have everything we need to tell us what kind of math we're going to do. That of tells us what goes on the bottom of the fraction. And so of tells us of total number of new cases goes on the bottom. So we're going to write that down. And the number of deaths is then going to go on top. And it's looking for percent. So we're going to have to multiply that by 100% to turn that into a percent. If we go ahead and type that in our calculator, we get something like 2.686. But it says round to the nearest tenth, so I'm going to just say 2.7%. If somebody tells you they've seen about 10 to the 50 commercials on TV, that's a bit of an exaggeration because 10 to the 50 means 1 with 50 zeros after it. That's a very, very, very large number. In fact, that's just 10 zeros, and that's not even 50 zeros, right? So 50 zeros is a lot. So we're going to make some estimates here to see how crazy of a number this is if they say they've seen that many commercials. First, we're going to assume that a commercial is about a minute long. And I know that's just a guess. We're trying to give ourselves a ballpark. So a minute. If they see a commercial that's a minute long, then that means in 1 hour, they could see 60 commercials, right? 1 hour, they could see 60 minutes, so 60 commercials. And then in 1 day, that's 24 hours, so they could do that 24 times. And then if they did nothing but watching commercials 365 days a year, then they could see that many commercials a year. So how many is that? If we actually run the numbers, and we can see that if we were to do this, it would cancel out, and it would tell us how many commercials they've seen and how many years of commercials they've seen. So that's 1.9 times 10 to the 44. That's a very, very big number. And that's in years now because we've canceled out all of our other units. So does it make sense? No, it's way too big for a number. If sales in a restaurant increase by 7% 1 year and decrease by 3% the following year, your sales are up by 4%. That's actually false. It's almost true, but it's false. Okay, and here's why. Because the 7% and the 3% are taking into account where we are at that given time. And so let's say we started with $100 in sales, and then it increased 7%. Then it's going to be at $107 in sales, right? Now, if I decreased 3%, well, I need to think about this because it's not $3 anymore, because 1% of 107 is $1.07. That's 1%. So 3% loss is actually losing more than $3. Okay, and so one way we can do this is we can go ahead and say, let's start with a 1.07, that's a gain, and we're going to multiply that by a 3% loss. So how do we represent a loss in percent? Is we go less than 1, so 97%. And if we multiply these numbers together, I'm going to go ahead and do it on my phone calculator here. We almost get 4%, but it actually doesn't work out exactly to 4%. It actually works out to 1.0379. Okay, so sales are up overall. You had the 7% increase, 3% decrease. We're still up, but we're only up by 3.79%. All right, let's have an exercise in some estimation. So first, let's talk about when we're estimating and doing approximate values, we don't need to worry about details and numbers that are imperfect. We're just going to round them to nicer numbers. For example, if you were to take 5.9 billion and want to know what it was divided by 200, well, the easy way to do that would be to treat it like it was not 5.9 billion, but 6 billion. And then divide it by 200. One of the nice things about that is we end up with a lot more zeros this way, and we can cancel those out. And then we end up with just the 6 and the 2, and so I end up with 3. And I'm going to see how many zeros I got left. 1, 2, 4, 5, 6, 7. So I have 3 times 10 to the 7. So that's my approximate value, and I rounded that 5.9 up to 6 and made that problem a lot easier. Now, the exact number, if I were to take 5.9 billion and divide by 200 in my calculator, I can go ahead and do that. And I'll get 5.295 times 10 to the 7th. Did that approximation get me pretty close to the right answer? Yeah, it did, actually. So I would say, yeah, it worked. It got me really close to the right answer. When we look at this problem, we're going to try to do an approximate calculation first. So 30 million divided by 110,000. Now, 30 million is a pretty nice, easy number to work with. So I'm going to type in 30 million, or I'm going to write it down here. 1, 2, 3, 1, 2, 3. Got to make sure I have the right number of zeros there. And then I'm just going to make the 110 million, or 110,000, I'm just going to make it 100,000, because that's pretty close. And then I'm going to cross out my zeros. And what do I get? Well, I just end up with 300 divided by 1. Okay. Now, if I actually plug it in my calculator, what do I get? 2.72. So I get 272, 273. So did that work? Yeah, it's actually pretty close. 272, 300, that's about the same. All right, this approximation problem requires us to be a little bit trickier about the approximation we choose. Now, 7,000 is pretty nice, but the 54,985 is kind of right in the middle. It's too high for me to round it all the way down to 50000 because it's 4, then a 9, then an 85. It feels like it should almost round up, but it shouldn't. It's like right in the middle. So we're just going to have to kind of work with it. We're going to say 7 times 55 with some zeros behind it. Now this one has 3 zeros behind it too. Okay, so we're just going to do the 7 times 55 with 3 zeros behind it. Now I'm going to use a calculator for this just to make my numbers come out nice. And I ended up with 7 times 55 is going to be 385. And then I have the 1, 2, 3, 1, 2, 3. I got the 6 zeros. So if I wanted to go ahead and write this out, I would go ahead and put the decimal here, and I'd have to move the decimal 8 places to get all the way over there. So now, that was kind of annoying because it wasn't as smooth, it wasn't as easy as the last couple. The exact value is really close to that though. So we're going to go ahead and plug that whole thing in our calculator, and we would get something pretty close. Did the approximation technique work? Yes, it did work. It is close. Now, personally, at this point, if we're already doing, I had to reach for my calculator to do the 7 times 55. But in a case where we don't have a calculator, we could have done that by hand pretty quickly. At that point, I almost would rather just do the whole thing by hand. All right, now we're going to try to avoid political statements on this one. If we have a statement like this, the CEO of a company earned more money than the last year than the company's 500 lowest paid employees combined. So we got to decide whether that statement makes sense. So we've got some choices here in our drop down for what the 500 lowest paid employees earn. Let's assume they're talking full-time employees. Now, a full-time employee works 2,000 hours a year. That's full-time. Okay. So how much in a year does the average person make? Let's say the lowest you can make. Well, it's not going to be $200 because they work for 2,000 hours. And so that would be $1 an hour if they made $2,000. So it's probably going to be closer to this one, the $20,000. If you were making only $20,000 and you were working 2,000 hours, that's making $10 an hour. And that's really tough. That's really tough. So that's about as low as I can imagine somebody getting paid and working full time. And I know people do it, and I feel for them. So let's see if this works out. The CEO of the company earned more money, according to this statement, earned more money than the 500 lowest paid. So if the lowest employees make on average 20,000, then the 500 of them would be 20,000 times 500. Well, that's 5 times 2. And then I'm going to have all those zeros after it. 1, 2, 1, 2, 3, 4. So according to this math, if the lowest employees make 20,000, which is really, really low, then we're looking at $10 million for the CEO when we combine it. Is that an unlikely salary? If you have a company that has 500 plus employees, you know what? I would like to say that that they should be paying their employees more. But if you have a company that big, would it shock you to hear that the CEO gets 10 million? No. That's actually pretty likely. It's pretty likely. So we're going to say it's not unlikely, and we're going to stay away from. We're going to stay away from the debate about whether that's ethical or capitalism and that sort of thing. Compare A and B in 3 ways, and so we're going to do the ratios and then talk about A as a percent of B. Now, this is comparing using percents and ratios to compare two values. We're not talking about percent of change here. So when it says ratio of A to B, what are we really asking for? Ratio is really a fraction. So ratio of A to B means we're going to write A over B. So the ratio of A to B, we're going to write 41,966,000. That's A. And then on bottom, we're going to put the B, which is 86,025,000. And if we just divide those two, the decimal we get is the answer there. And to find the ratio of B to A, what do? We flip it upside down. We flip it upside down and we just plug them in. So to complete the sentence, we're going to take that and I'm going to plug it in my calculator because I do want to know what it is. It's 41966,123. And so I got 0.487834, blah, blah, blah. So we want to pay attention to what it's asking us to round to because we're going to have to round this to something. Maybe it says 2 decimal places and we need 0.49. Maybe it says 3 decimal places and we need 488. Okay, so pay attention to that. I'm going to say 3 decimal places is 0.488. If we wanted it as a percent, what would we do? Well, we'd multiply it by 100. So I'm going to say times 100. That's going to be 48.8%. And that would be the answer to part C. So the only difference between A and B is that what do we put on top of that fraction? To make that ratio into a percent, we just need to multiply by 100 and move that decimal place. At the end of a year, the gross debt of a country stood at about 23 trillion. Okay, so we've got 23 trillion. I think that's going to be useful. And then we want the dollars per person when the population is 279 million. So in this situation, we have all the information to do the amount of dollars per person. Now, dollars per person is what they wanted for. Dollars per person. So even if you didn't really know gross debt, what they're talking about, since they said what they wanted, and we know that per means divide, and they told us the units, we get to just plug in the information they gave us and roll with it. Dollars per person means we're going to plug in 23 trillion on top. That's billion. Oh man, there's a lot of zeros in trillion. And then 279 million. And we're going to go and divide those until we get our answer. Now, this person, somebody sent me this question, and I actually left the answer they put in, which is actually what I got too when I plugged in the answer. So you might wonder, well, why'd they send it to you if they already got the right answer figured out? Because it says type a whole number and round to the nearest 100. And so the answer that the assignment was looking for was not all this detail. It was actually just 82,400 is what they were looking for. They wanted it round to the nearest 100. Through hard training, Miko improved her 5-kilometer running time by 110%. So let's just for a second just make up a time for Miko on her 5-kilometer. Maybe her 5-kilometer time was 30 minutes. 30 minutes. And if she were to improve her 5-kilometer running time and cut it in half, that'd be a decrease of 50%. If she were to decrease it by 50%, it would go down. 50% of that is 15 minutes. And that's pretty good for a 50% improvement. That cut her score in half. However, if she were to decrease it 100%, what is 100% decrease of 30 minutes? That means she does it in 0 minutes. So that's going to be a bit of a problem. I don't care how hard she's been training. She's not going to get it down to 0 minutes. And actually, the claim is that she improved by 110%. So she got down to negative minutes. That doesn't really make sense. So I'm going to say this claim couldn't be true. Might be a bit of an exaggeration. All right. If you have the percentage of smokers in a certain country and it's decreased 27.7%, it's decreased that much. It went down 27, and it ended up at 15.5%. The question then asks, well, how much was it to start with? And it's very tempting to go, well, it was 27.7% to start with. No. It's not 27% when we started with. We started at something. We were here. We went down, and we ended up at 15.5%. So you might go, okay, so we just need to figure out what the 27%, we're going to add the 27% back on. And if you do that, you might be able to get there. Although, to increase, we aren't increasing 27.7%. So we're going to take another approach at this. So we know where we are. We're here. And we know where we were. Well, we know it was 100%. We know we decreased 27.7%. If we decrease 27.7%, what percent are we at now? If we just talk about as a percent of what we started with. And so that ends up being 72.3%. So we've got that 27% increase or decrease. And so now we have our percent that we started with. And if we want to just cross multiply and divide, we can solve this like a proportion. We can actually solve this like a proportion. So I'm going to try typing this in my calculator. I got 15.5 divided by 72.3 times 100 and I got 21.4%. In other words, it was at 21.4%. It decreased 27% of what? It didn't decrease 27% percentage points. It decreased 27% of that 21% went down. And it ended up at 15.5%. So we want to kind of work backwards on this one. All right, we've got a statement here that we got to decide whether it makes sense. And the statement is, I've decreased my caloric intake by 111%, and it's helped me lose weight. Now, I think decreasing your caloric intake would probably help you lose weight. But if you decreased it by 111%, that I don't think would be very wise. Because if you were normally eating 2,000 calories and you decreased by 111%, well, that means you'd be decreasing by 2,220 calories. And so what happens if we decrease by that many calories? That means every day I need to eat negative 220 calories. Okay? If I eat negative 220 calories, I will lose weight. Well, this doesn't say are my net calories. This is my caloric intake. And bottom line, you can't eat negative calories. But even if you did, this would be a ridiculous way to lose weight. You shouldn't go under even 1,500, 1,200 calories as a regular habit anyway. So this is unsafe and actually ridiculous.